All right, honors. I'm going to give you at most 15 minutes. I am on the objective that says I can solve. It's one of the two learning objective twos. And I am actually going to go and start with the second page or the back of the front. Question number 10. I want to take a look at a couple of the logs, but then I also want to look at like 13 and 14 and 15 just to explain a few more things to you. So on number 10, when you are solving for x and x is an exponent, we will have to loop it into a log. Before I can loop it, it's got to be just the base and the exponent. So first I'm going to add the 3 to the other side for 10, and now I'm ready to loop. Look at the loop. It loops into a log. The base of the exponent is the base of the log. There goes the 10, and I finish with what it equals. I have to use the change base formula, so I take log 10 and I divide it by log 6. As it turns out, this is worth about 1.285. That will equal the negative 0.2x, just continuing along. And now to get x by itself, I divide, and when I'm done, my answer for x ends up being negative 6.43. Okay? Number 11 is also an exponent. I will have to loop it into a log. So look at the loop. It goes log e, which is the same as ln, and then goes to 3.8 equals 3x. The natural log of 3.8 is 1.34. So after that equals 3x, and I divide by 3, I get about 0.445 as my answer. All right, I went over 12 in class. I'm going to start with 13 now. What I'm going to do, and if you look at the printable answer key, I tell you the common denominator between the two. It's h minus 1 times h plus 4. So what I'm going to do is build up the left one by multiplying times h minus 4 on the top and on the bottom. And I'm going to multiply the other one by h minus 1 on the top and on the bottom. So I know for a fact that the bottom is going to be h minus 1 times h minus 4. So for the denominator, I will just end up foiling this, which I'm going to go ahead and do, and write that down first. So when I FOIL, I get h squared minus 5h plus 4. My numerator, when I take the h times h minus 4 here, I get h squared minus 4h. Going to the other fraction, when I multiply h with h minus 1, I get h squared minus h over the same denominator, and that equals 1. So from there, I'm just going to kind of move up, because I'm not doing all these problems. I can take more room. I'm going to combine my numerators right here. And so when I combine them, I get 2h squared plus negative 5h over my denominator. And that equals 1. And I'm actually going to put it over 1 because I'm just going to do cross products. So when I multiply, I get h squared minus 5h plus 4. Cross products the other way is just 2h squared plus negative 5h. And since I have more than one type of h, I'm going to bring everything to one side. But what I do notice first is that they both have a negative 5h, so I'm going to cancel those out. And now I'm going to bring the h squared and the 4 to the other side. And so when I do that, I just end up with h squared minus 4, factor it. And so my two answers are 2 and negative 2. All right, I'm going to take a look at 15. So I'm going to do a little racing first. All right, on 15, the common denominator I'm going to go for is x plus 2 and x minus 2, because this is x plus 2 times x minus 2, and this one is x minus 2. So what I'm going to do is build up the left one by multiplying by x plus 2 on the top and the bottom. My middle fraction, or I'm sorry, the 1 over x squared minus 4 is good. So instead, what I'm going to do to the 1 is just multiply by x squared minus 4 on the top and on the bottom. So on the left side, when I multiply x plus 2 times 2x, I get 2x squared plus 4x over my denominator. My 1 over x squared minus 4 is okay. And when I take the 1 times x squared minus 4 over x squared minus 4, that's what I get. Since the denominator is all the same all the way throughout, I'm actually just going to ignore it and focus on the numerators. So the left side, 2x squared plus 4x. The right side, I'm just going to clean up into x squared minus 3. And since I have two types of x, I'm bringing everything to one side. And when I do that, I get uh, x squared plus 4x plus 3. And then I can factor into x plus 1 and x plus 3. And I get my two answers of -1 and -3. And that is the answer to 15. All right, I am going to take a look at 17 on this page, and I'm going to take a look at 18 on this page. So I'm going to do a little racing first. All right, on 17, again, I'm solving for x, and it's an exponent, but I won't be, I can loop if I want. So if I loop, again, it loops into a log. So here goes the loop. So I can do log 125 of my fraction, and that will equal the exponent of 5x plus 4. But I could also, for this problem, get a common base. And so if I look at my cheat sheet, I want to find a common base between 25 and 125. And on my cheat sheet, that base ends up being 5. So what I'm going to do is show you this way instead, because on the printable answer key, well, I think I showed you on the printable answer key this way. To get 1 over 25, it's just to a negative exponent. The -2 brings the 5 squared to the denominator. 5 cubed is 125, so this is still 125 to the 5x plus 4 power. But now that the bases are the same, I can just solve with my exponents. So I'm going to go ahead and distribute the 3 into the exponent here. And then now to solve for x, I am going to, I'm going to bring the 12 over, and then I'm going to divide by 15. So my actual answer is -14 over 15. And on the printable answer key, I accidentally wrote -1 as my exponent right here instead of -2. So this is the correct answer instead of what you guys see on the printable answer key. All right, 18. 18, when we did this section, there were some common mistakes. The first mistake was, what do you move first? The first thing you move when you solve for x and you're trying to get x by itself is the addition or subtraction. So the first thing I'm going to do is move the 4 to the other side. Then, to get x by itself, I'm going to undo my multiplication division. So I just divide by 2, which gives me 1 on the other side. And now to get x by itself, to undo the cube root, I cube both sides. So when I cube the left side, that makes the cube root go away. Then I will cube the other side, and it's 1 to the 3rd power, not 1 times 3. So now I'm going to solve for x, bring the 1 over, which I get 0, so x is just 0. All right, I'm on the next page. I want to take a look at some of the solving with log problems. Again, if I see logs or exponential functions and there's a constant, I need to condense. So that's what I'm going to do on 22. But before I condense, I've got to get this left side down to 1 log. So temporarily ignoring the logs, when I see x plus 1, this plus is going to turn into a times. So condensing it down, I get x squared plus x. Now I'm going to bring the log back that I've ignored because I need that log for the loop. So here goes the loop. 2 to the 1st power, which is just 2, equals x squared plus x. Because I have more than one type of x, I'm going to bring the x over, or I'm sorry, the 2 over. And factors of 2 that get me to -1 are going to be +1 are going to be x plus 2 and x minus 1. So my two answers are -2 and 1. Let's take a look at number 20. Again, I need to loop it. It is an exponent problem, so I'll loop it into a log. But first, I got to have just the base and the exponent. So I got to move the 5 and the 2/3. First, I'm going to move the 5, which turns 8 into 3. Then I'm going to multiply by the reciprocal. So that makes 3 turn into 4.5. And now I'm ready to loop. So watch the loop first. It becomes a log. So log e, which is just ln, 4.5 equals 4x. The natural log on the calculator of 4.5 is 1.504 equals 4x. So when I divide, there's my answer, 0.376. All right, I'm going to jump to the graphing. So if you look at the problems, I'm going to go over number 11. Um, on number 11, first identifying A and B. A is a negative 1. If you actually look here, I'm going to rewrite this problem. A is negative 1, which is my y-intercept. B is E, or 2.7. And since B is bigger than 1, I will have a growth shape. My left-right number, there is none. My up-down number is 2, which will then be my wall. Since it's just an exponent problem, I actually don't even need 2 bars or 2 t-charts. So finishing it up, since it's growth, I'll use 1 and 2. And when I make my t-chart, I will just use, I will leave out h and k. So this is my t-chart. So if I put 1 in there, e to the first power is 2.7 times negative 1 is negative 2.7. E to the second power is about 7.4. So when I take that times negative 1, I get negative 7.4. So when I graph these, I am just going to estimate them on the graph. I'm sorry. No, that's correct. So actually looking at my answer key, I put negative 5.4. I put the wrong number. Same shape though. All right, so here is 0, negative 1. Here is 1, negative 2.7. And then 2 with negative 7.4, about negative 7.5. Now what's going to happen with this shape, because A is a negative 1, this shape that I drew the first time is actually going to flip. And it's going to look like that. But first I'm going to shift all of my points up 2. And I can draw on my shape. All right. Real quick, just to talk about the t-charts. What should you use for your t-charts as you go through them? On number 10, you should just use 2 times 1/4 to the x power. You do not need the second one. On F, the one all the way to the right, it is 5 to the negative x. You don't need both t-charts, but you will want to use negative 1 and negative 2 because it will be decay. On this one, you will use t-charts. For the exponents, you'll use e to the x, and then don't forget to flip it. And the same thing here for the t-chart only. I think that's it, you guys. The printable answer keys are very thorough. We answered a lot of questions in class. So good luck. I'll see you on Monday. Don't forget your cheat sheets.